Yeah, so this is Professor Ashish Malgave. So here I'm going to share the few things regarding power quality monitoring, as the power quality monitoring is important factor right now. So we are going to deal with the power quality monitoring. So what are the different factors that we are going to consider and why we are going to consider while power quality monitoring? So that we are going to discuss here. See, simply, so this monitoring of the power patterns, so how the power patterns are there, so all these points that we need to cover in this chapter. See, so first of all we need to learn why the power quality monitoring is essential. What are the reasons, or what is that reason? So for that, the power quality monitoring is essential. So there are three factors that increase the need for solving and preventing power quality problems, also increase the need for power quality monitoring also. So whatever the power quality issues are there, so power quality issues such as voltage sag, voltage swell, interruption, short duration voltage variations, long duration voltage variations, all these are the power quality issues. And as per as our electrical system or electrical stability is concerned, so all these issues that we need to eliminate by using some means. So first of all we need to find it out which type of either which type of power quality issues are available, and then we are going to monitor that in proper way. So that's why you can solve the power quality problems in a proper way. See, the increasing use of power quality sensitive equipment right now, as we are going for the automated systems. So as we are going to use the electronic devices, more electronic devices. So so the increasing use of power quality, that means there are sensitive equipments are there. So if the power quality issues will be there in your power system, because of that sensitive equipment, you may get what you can say problems in your power. So that's why, so we have to think on this, and we need to monitor the power quality in a proper way. So increase use of equipment that generates power quality problems. See, so we have increased the use of power quality, that see simply, if we are going to think about the rectifiers, inverters, or converters that we are going to use in some active filters, passive filters that we are going to use. So all these where the electronic devices are there, and these electronic devices are responsible to to get some power quality issues. So that's why, as we are going to increase these electronic devices, so definitely power quality problems are there. So sometimes you will get harmonics also. Again, there are n type of harmonics. So you will get even harmonics, you will get the odd harmonics. But the important thing is what? So initially we need to monitor which type of power quality problems that is there in the power system, and accordingly some filters or some precautionary measures, or otherwise some, what you can say, measures that we can take to prevent that power quality issues. The deregulation of the power industries. So again, the thing is whatever the power industries are there, where the deregulations are there, so all these points that we need to consider for the power quality monitoring. Now, first, utilities need a power quality monitoring when the customers use the present day highly sensitive computers and computer controlled equipments that requires a power source of a higher quality and more reliability than standards, less sensitive electricity consuming equipment. See, as day to day life, we are going to use the computers more and computer controlled equipments more. At the same time, the higher quality and more reliability standards that we requires. So that's why this power quality monitoring, at the same time power quality issues that we need to solve it. So that is what the actual work of the power engineer. So traditionally, utilities did not get involved in the power quality problems that occurred on the customer's system unless contacted. So traditional method was there. If there is a problem, then the actual person that is going to come to your location. So where the problems are there. So that is what the traditional method. But if you are going to think about the traditional method, because of the traditional method, there may be a chances of equipment damage. So that's why instead of going for a traditional method, we need to go for a proper method. Otherwise, that automated method that we are going to think. See, when contacted, the utilities approach was to determine the cause of the problem and who is cause it. This approach no longer works in a competitive environment. So traditionally, the method is same. So utility approaches, at the same time why that problem was there and who is caused that problem. All these points that comes in front of all of you. But if you are going to think about this competitive environment, so such type of traditional method is not good for the power system. So that's why if the problem is coming, so we need to find it out at the same time and accordingly. So same thing that is reach to that particular person who is going to solve it. So that kind of process that we need to involve in the power system, so that, so if you are getting a problem immediately, you can solve it immediately. So this is what the competitive world, so that all these points that we need to do at the same time. Many utility customers expect high quality power without problems. See, many utility customers that we requires the high quality power without problems. So many utilities and their customers find a permanent power quality monitoring system an effective tool that prevents and solves the power quality problems. See, so that's why the problem of power quality monitoring comes in a picture. And so at every instant, at every time, we need to monitor the power by using computers, and we need to take a data continuously. And if you are getting a problems, that data that can be received by that particular person, so who is going to solve the problems related to the power quality issue. So this is very important factor. So that's why the monitoring of the power that plays a vital role. Second, programs to improve the efficiency of producing a high efficiency of production have resulted in use of non-linear equipment like adjustable speed drives or power factor improving shunt capacitors. These devices often generate or amplify the existing harmonics that distorts the voltage waveform. See again, the point here, the non-linear equipments that we are going to use, like an adjustable speed drive. So we are going to use the variable frequency drive. So all these non-linear equipments, these are the few cases I'm telling you, but you can use, we are going to use a n number of what you can say uh, non-linear equipments. This plays a, because of this we'll get a more power quality problems. Now here, these devices often generate or amplify the existing harmonics that distorts the voltage waveform. So as existing harmonics are there, so that distorts the voltage waveform. See, there are even and odd harmonics. Now if you are going to think about the equation of the voltage, then, and if you are going to use the Fourier transform or Fourier series, so you will get a long equation where you will get odd harmonic and even harmonics. So odd harmonics are dangerous to the power system, and as far as the third harmonics and fifth and seventh harmonics are concerned, so these are harmful to the voltage and current stability. So that's why the power quality monitoring is important. These distortions can get on the utility system and affect the interconnected customers. In addition, increased use of the arc furnaces causes a voltage flicker, that in turn causes a light to flicker and irritate the people. again the flicker, voltage flicker, that is what the power quality issue that you will get because of increased use of the arc furnaces. Now, new type of loads such as electron beam furnaces for melting titanium and induction furnaces for processing aluminum generate harmonic voltage distortion. Large horsepower motors, see, there are n number of cases where we are going to use the large horsepower motors. So all these motors, if you are going to think about the induction furnace, so because of this, you will get a voltage dip and large inrush current during startup. See, so if you take any motor such as a DC motor, induction motor, so initially when you are going to start that motor, so initially the current taken by that motors, that is more. So in short, that we can call that as a inrush current. And if the inrush current taken by that motors are more, then ultimately you will get what you can say voltage dips. So in simply in short words, that we can say the voltage sag that you will get. So all these types of loads results in a one customer causing a power quality problems for another customer. See, as the if you are going to think about the utility system, so after distribution we are coming towards the utility system. So as any one of the equipment, if that is non-linear equipment is there, so because of that you will get what you can say power quality issues or power quality problems. And if one of the customer is getting the power quality issue, so impact of that is what the second customer also get the power quality issue. So that series of power quality issues that you will face. So that's why whenever you are going to use the motors of a high large horsepower, so in that case you will get that voltage dips or large inrush currents because of that large inrush currents. Now third, the deregulation of utility industries will cause many customers to choose utilities that can supply power that is high in quality as well as low in cost. Consequently, utilities will retain existing customers and attract prospective customers by showing them that they can deliver power with a high quality. See, there are some utility industries, so they want uh, power with a high quality. At the same time, they want the power at a high quality and low cost. So everyone needs that. So such utilities with power quality monitoring system will need to convince existing and prospective customers that they see power quality not as a problem but as an opportunity to provide the customer service and become more competitive. Now suppose if we are having the industry of what you can say power quality monitoring, or if you are going to solve the power quality issues, then so you have to change your perception and you have to tell them that if you are going to monitor the power quality in a proper way, then we can solve that issue within a short period of time, so that whatever the power that you are getting, that power that is a good quality power every time that you are getting, and because of that you will get a duration or durability of that material or equipment that is going to increase. So that's why, so you need to focus on the power quality monitoring, and we are the service provider for the power quality monitoring and power quality issue, and we are the solving the power quality issue. So that kind of perceptions that we have to make for the industries, where utility industries, so that they are going to monitor that power quality, and at the same time, so we have to solve the problems related to the power quality. So utility customers will become more competitive when they receive a power in a high quality and reliability. How will the deregulated competitive utility industry affect the evaluation of the power quality monitoring? See, so how will the deregulated competitive utility industry affect the evaluation of power quality monitoring? See, deregulated competitive utility industry is there, and they are tuned with the Indian system. Yes, so there may be a chances of what you can say current so power of kind of problems they are that are always there. So So deregulated competitive environment is there. So that's why, so how you are going to give the inputs to the utility industries, that you need to go for the power quality monitoring. So that is very important. And so that is what the part of the service industry. Suppose if you are having the service industry. Now next point that comes in a picture, that is what evaluation of the power quality monitoring. A comparison of the evaluation of the power quality monitoring system to the evaluation of utility transmission and distribution system reveals some interesting similarities. As the need for for a more reliable and efficient electrical power system grows, the utility transmission and distribution system increased in complexity and the voltage. As the need for higher power quality increases, utilities and their customer needs prompt and immediate information about the power quality at the transmission, distribution, and end user levels. See, in day to day life, so everything that are related to the power, and where the uh, higher power quality, that in the need of higher power quality that increases. So that's why at any level, if you are going to think about the power system where the transmission, distribution, and utilization is there, so customer what they need a prompt and immediate information about the power quality. So power quality systems have become more complex and sophisticated. Utilities and their customers find it costly and insufficient to install the power quality monitors after the power quality problem occurs. They need ongoing up to date power quality information. They will need this information even more when the electric utility industries becomes deregulated. So all these the parts of the evaluation of the power quality monitoring. So how it comes in a picture, how the evaluation of the power quality monitoring is there. Okay, so everywhere, so the utility industries, the transmission industries, the distribution industries, or the peoples, those who are dealing with the industries, so everybody wants the high quality power, high power quality. So that's why the power quality monitoring comes in a picture. See, this is what the diagram. So deregulations effect on the power quality. See, so where we are going to install the power quality monitoring, and what are the effects that you will get. So again, this is very important, that if you are going to use the power quality monitoring equipment at a generation level, at a, what you can say, transmission level, and at a distribution level, then you can come to know that, so where actually the power quality problems that you are getting, and at what level that power quality problems that you are getting, that you will come to know that. So simply whether the problems is in the transmission part, whether the problem is in the generation part, or whether the problem is on the distribution level. So all these that we can find it out by using power quality monitoring devices. So all these are the parts of the power quality monitoring. So here we need to check the power quality at a different stages, so that if the issues that you are getting, then we can solve it by using some means. So the need to determine the source of the power quality problem. Yes, this is what the first point. So where actually the problem is there, that we need to find out first. Then the need to determine the source of power quality problems will become imperative when utilities break up into a separate companies. Permanent power quality monitoring at a point of interconnection becomes GenCos, Transcos, and Discoms, or at a distribution level, or at an end user level, will be necessary for determining the source of power quality problem. Now here important task is what, where the source of power quality problem is there, that source that we need to find out first, and then we are going to think, so how we are going to solve it. So historically, so power quality engineers installed monitoring equipment at the point of common coupling. The point of common coupling is the point where the utility connects to the end user customer. After the monitor collected the data for a week or two, someone would have to go onto the site and download the data, take the data back to the office and analyze it and determine the cause of power quality problems. This approach was time consuming and insufficient. See, historically, or we can say traditionally, how the process is there, all these different categories of the transmission line or the power system is there. So generation is there, transmission, distribution, and utility is there. So all these four parts are there. So if you are facing a power quality problem, then we need to send the person to that particular place. So he is going to check there with which type of problem is there. Then he's coming to the what you can say, that particular office, and he's telling to the power engineers such type of problem is there, and the problem is facing at this level, so how we are going to solve it. This is what the traditional method, but this approach is what you can say time consuming approach is there, and this is inefficient approach. So that's why, so we need to go for the method where that process that is going to be a fast, and you will get the details immediately. So that kind of systems that we need to involve. A more efficient approach involve the use of new types of meters. That means we are going to use the new types of research. These, what you can say, meters allows the power quality engineers to access the data remotely. So this is very important. Again, these meters where the SCADA system, if you are going to think about the SCADA system, the supervisory control data acquisition system. So you can check the data, you can take the data remotely, and by using that data you can think that yes, this is what the problem and this is what the power quality problem. So if you need to solve that problem, either we have to go to that site particularly, otherwise remotely, whether we are going to solve it, that we need to check it out the service level or at that particular level, and accordingly you have to take the decisions and you have to maintain the power quality. So even this approach has its limitations. It worked when only few temporary meters were required. Present and future power quality monitoring will require several meters at many sites installed permanently to monitor the power quality for a statistical or a diagnostic analysis. Engineers can use statistical analysis to determine the relationship between power system configuration and the power quality to show the deviation from the power quality standards. Again, some type of, what you can say, statistical analysis or some system configuration that we need to incorporate, so that we can check the deviations that you are getting in the power quality standards. Now here, the power quality monitoring system using the internet. So how the power quality monitoring system that we can install, and by using internet how we can access the data remotely. So here there is a diagram. At each level we are going to connect the computers. So on the computers or on the display you will get the power quality, and if there are issues that we need to send back by using internet, and the power engineers that we need that he is going to study, so which type of power quality problems is there, and accordingly he is going to uh, solve it remotely, if that possible, then remotely, otherwise he need to come to that site particularly, and accordingly he is going to solve that power quality issue. Now what are the different uh, measurement tools that we are going to use for the power quality measurement? So first one, that is wiring and grounding test devices. We are going to use the multimeters, oscilloscopes, disturbance analyzers, harmonic analyzers and spectrum analyzers, combination of disturbance and harmonic analyzers, flicker meters and energy monitors. So all these different power quality measurement tools that we are going to use. Other instruments that can be used to help solve the power quality problems are measured at ambient conditions. Many times we can use infrared emitters, can be very valuable and detecting the loose connections and overheating of the conductors, and annual procedure of checking of the system in this manner can help to prevent the power quality problems due to arcing, bad connections and overloaded conductors. So noise problems related to the electromagnetic radiations may require a measurement of the field strength in a vicinity of the affected equipment. Magnetic Gauss meters are used to measure the magnetic field strength for inductive coupling concerns. So electric field meters can measure the strength of electric field for electrostatic coupling concerns. So static electricity meters are special purpose devices used to measure the static electricity in the vicinity of a sensitive equipment. So electrostatic discharge, that is ESD, can be an important cause of power quality problem in some type of electronic equipment. So number of important factors that should be considered when selecting the instruments. So first thing is how many number of channels are there. So whatever the particular equipment that we are going to choose for the power quality monitoring. So while choosing that equipment, so what are the factors that we need to check it out? So that factors are given here. So first factor, that is number of channels. Second one, temperature specification of the instrument, ruggedness of the instrument, input voltage range from 0 to 600 volt. So power instruments, so ability to measure a three-phase voltages, input isolation, ability to measure the currents, housing of the instrument, easy to use, documentation, communication capabilities, and analysis software. So all these factors that we need to check it out. So while using that device for a particular monitoring level. So these are the different equipments and equipment related, what you can say, uh, the factors that we are going to consider, that we are going to check it out here. So next, so equipment level, or each equipment that we are going to study in the next part. So next part, so kindly tune with your next part, and we will stop here.